Thank you. Muy buenos días a todas y todos por acompañarnos en la presentación sobre el tema energético relacionado con la desalinización de agua de mar. Este es uno de varios temas técnicos de energía que nos han propuesto que propongamos algún experto dentro del programa de la iniciativa de Net Zero World en la transición justa. Un par de cosas que quiero recordar a todos es que contamos con el intérprete, contamos con la traducción simultánea. Les pedimos por favor de elegir el idioma al que quieran escuchar. Abajo en su pantalla encontrarán un botón que dice interpretación o intérprete. Entonces, si desean escuchar en español, por favor pongan español, y si quieren inglés, en inglés. Bueno, también les recordamos que este seminario web está siendo grabado y estará dispuesto posteriormente para quienes deseen volverlo a ver o a quienes no estén pudiendo asistir el día de hoy. Finalmente, antes de comenzar y presentarles a la persona, al orador del día de hoy, les quiero recordar que tenemos todavía, este es el quinto seminario técnico, tenemos todavía 3 más programados. El próximo será de hoy en 8, el próximo viernes 25 de agosto, y el tema será sobre mini redes, cuáles son los beneficios, los usos. Hablaremos incluso de casos específicos en la utilización de mini redes en caletas de, de pesca. Bueno, sin más por el momento, quiero presentarles aquí, por favor, a Jeremy Crutchfield, que es un experto en el tema. Y por favor, Jeremy, adelante, danos un poco de tu background y de la empresa, y adelante. Muchísimas gracias a todos.
Thank you, Ricardo. I appreciate the introduction. Again, my name is Jeremy Crutchfield, and I'm a water resources manager for the San Diego County Water Authority. And I'll provide some more background on my agency in a little bit, because it kind of helps tell the story of why we pursued seawater desalination. And before I get into the specifics about the desalination plant itself. A little bit about myself. I'm actually a civil engineer. I've built, constructed, and designed a lot of our infrastructure at the Water Authority. But recently I transitioned into planning and policy and water resources. And in that role, one of my jobs is purchase of water. So that's what we'll be focusing on today. Advance the screen here. We go. All right, so first, a little bit about the San Diego County Water Authority. We are a wholesale water agency, which means we don't necessarily sell to residents, people, businesses directly. We sell to cities and utilities in San Diego County. We've been around for a long time. We were formed in the 1940s to be the wholesale water provider for the entire county. And we're represented by 24 different member agencies, which are City of San Diego being our largest. We serve about 3.3 million people and support an economy of about $268 billion. And I definitely want to talk about water reliability and how that plays into the San Diego economy and the importance of a reliable water supply as we transition through this project in this presentation. This presentation is a little unique in this webinar series. You know, the water energy nexus is very important as we're considering the transition to decarbonize the energy system, the energy grid. We have to take into consideration the water production, water conveyance, that takes a lot of power, and we need to deliver water 24 hours a day, 7 days a week, 365 days a year. So when we're looking about transitioning our electric grid, we need to think about how that impacts the water delivery, and those need to be looked at a lot more closely. And so that's something that we're seeing the industries do, and partnerships moving forward. San Diego County is in the southern part of the California state along the coast. We are just north of the border with Mexico. And you can see us here in the star in the bottom left-hand corner. And our water comes from a long way. In San Diego County, we're actually, while we're coastal, we do not get much rain. We have less rain than a lot of the deserts in Arizona and in Mexico. We only get about 10 inches of rain a year. We also don't have geology to support groundwater. So we have to import most of our water, and it comes from a long distance. A lot of our water comes from the Colorado River from the east, and then also from the State Water Project in the Sacramento Bay Delta in the north. And so there are a lot of pipelines and pump stations to get that water down to San Diego. So that's one of our challenges. Being a large economy, a large population, water supply is very important, and we have to do a lot of planning to make sure we have that water. And to kind of tell our story, we kind of look back 20 years, 30 years, and this is our path that we have taken over the last 30 years to diversify our water supply. And I'll start previous, in the 1990s and earlier, all of our water was imported from outside of the region, or nearly all of our water. We buy water from the Metropolitan Water District of Southern California. They're up in Los Angeles, just to the north of San Diego. And we relied on 95% of our water coming from them. And that water came from, again, the Colorado River and the State Water Project. In the early 90s, we were in the middle of a multi-year drought. And we were cut back about 30%. We lost about 30% of our water. And there was the potential to lose up to 50% of our water supply for San Diego. That impacted everything. It impacted our businesses. It impacted agriculture. It impacted our quality of life in San Diego. Fortunately, in 1991, we had what we called a miracle March. We got a lot of rain that filled our reservoirs and took us out of drought. But our business community, our farmers, our residents of San Diego County said never again. And they tasked the Water Authority to diversify our water supply portfolio and not be reliant on all of our water coming from outside of our region. So over the last 30 years, we've invested a lot of money, and we've started that diversification process. And it's made up of a lot of different components. Seawater desalination is just one of the many components. I'm not here to sell that seawater desalination is the silver bullet or the answer to all of our water concerns. It's just what we call a tool in the toolbox. One of the ways we diversified, though, was working with our farming communities, not only in San Diego County, but other counties, to work on conservation measures to reduce water use in our agricultural sectors. So we were able to work with them and fund a lot of those programs. And in return, we got senior rights to water on the Colorado River. We also lined concrete or earthen channels that brought water down to San Diego. So we would lose a lot of water through that process of conveying it down to San Diego. And by lining it with concrete, that water no longer seeped into the ground. And we were able to conserve and produce a new water supply. We also have water recycling. That's been a major program in California to reuse water. We're transitioning now to potable reuse, which is turning wastewater into drinking water. And also, we do have some reservoirs and some runoff capture, but what we'll focus today is seawater desalination, which is shown here in orange, and it represents almost 10% of our water supply in San Diego County. So why seawater desalination? Well, for the main reason is resilience and reliability. The Pacific Ocean is the largest water source in the world, and it's right on our doorstep, right on our right outside our windows. So we had immediate access to locally controlled, locally available water. It doesn't depend on snowpack. It doesn't depend on rainfall. It's always there and available. It is also the process of seawater desalination produces a very high quality water that doesn't have much salt or salinity in it. And so that's an advantage for a lot of our residents and farmers as well, to remove a lot of the salts from the water before they use it. Seawater desalination also, as I mentioned, gave us local control of water instead of having to import it from a long ways. And it's something that complements reuse and recycling. Seawater desalination is a new supply that can be used over and over and over again through our recycling and our potable reuse projects. Now I'll focus specifically on the Carlsbad desalination plant in San Diego. It's a 50 million gallon per day facility. It is the largest seawater desalination plant in the United States. We talk in acre feet when we talk water. 1 acre foot of water is enough to serve about 2 or 3 families for a year, just to understand the quantity of water we're talking about. This facility can create 48,000 to 56,000 acre feet per year. And that's enough to serve about 400,000 families in San Diego County. Again, this is 10% of our water supply. The facility was developed through a public-private partnership. That means we partnered with the private sector to build and develop this facility. The reason we did that is, as a public entity, we're pretty risk diverse. We know how to move water and to distribute water, but the treatment of water is not one of our expertise. So we leveraged the expertise of the private sector to build, develop, and operate this plant. It also meant, by building it through a public-private partnership, that the risk transfers over to them, not only the operational risk and the development risk, but they also were required to permit the facility and to finance the facility. The plant was completed in 2015, so we've been in operation for about 7 years, and I'll talk more about that a little later in the presentation. After the 30-year term of the contract, the facility would turn into a public asset, and so we have the option to take over that plant and incorporate it into our system. So a little about the contract and the partnership with the private sector. The Water Authority is under an agreement with Poseidon Channelside as the private entity. And again, they were responsible for developing, permitting, financing, and now operating the facility. They hired a contractor to do the design and build the plant. They also hired IDE Technologies to help design and operate the facility. IDE is an Israeli company, and they own and operate many of the seawater desalination plants around the world. So they're a very reputable company. The Water Authority's infrastructure, however, is not along the coast. And so we also had to build a 10-mile pipeline to bring the desalinated water into the Water Authority's system. Now, pipes and water movement and conveyance, that's something we do know. So we entered into a different type of contract to design and build the pipeline. But once it was constructed and commissioned, we took over operations. So we actually own and operate that pipeline. We just don't own and operate the plant directly. So I talked about the economy of San Diego, and one of the things that the business sector and the farming sector mentioned back in the 90s was that water was a very, very valuable and necessary component of their success and the growth and success of our economy. And so water reliability was something that, again, we prioritized and had partnerships with our business sectors and industrial sectors to promote and achieve the diversification of our water supply. And, for San Diego, we do have a large economy. It has agriculture, it has biotech, it has manufacturing, pretty much any sector of the economy or the workforce you can think of is in San Diego, and water supply touches all of that. But it's not just the water supply that ties to our economic growth. The facility itself produced a lot of jobs and a lot of opportunities. The construction of the plant introduced about 2,500 new jobs to our communities in San Diego. A lot of those are the trades. And one thing that we are seeing in the US, but specifically in California, is our trade sector aging, getting older. And so we're really trying to get our younger students, to look at the trades, look at becoming a welder, a pipe fitter, an electrician. Those are trades that are great jobs, and a lot of those were obviously hired and employed into the development and construction of the desalination plant. We also have to look at all of the different vendors and suppliers and sales force and other indirect jobs that are created in the construction of the facility. It took 3 years to construct, so it was a large engagement of different trades getting into the project. The operation of the plant also employs a lot of different players. Now, only about 45, 50 full-time staff are at the plant to operate the facility. But then you have to look outside of that. The folks who are doing our monitoring, our testing, our lab technicians, supply of chemicals, materials, equipment, vendors. There's just a lot that goes into the operation and maintenance of a facility of this size. And so you're again looking a lot of job growth in our area and a lot of economic opportunities related to the facility itself. Now, this schematic kind of shows how the construction of the facility and was integrated into the regional system. A lot of times when you look at seawater desalination, people believe that it's just the coastal communities that get the benefit of the water, of the high quality water. And that's not necessarily true for our facility. As I mentioned, here on the left, you can see where the desalination plant was constructed right along the Pacific coast. We built a 10-mile or 16-kilometer pipeline to connect to our infrastructure that was inland. We brought that water up north to mix and combine with all of our other treated water that comes into the San Diego region. We have multiple different supplies, and this is a traditional treatment plant up in the northern part of our service area. We blend that desal water at this location and then serve that blended water to the rest of our community. About 95% of our customers get some component of desalinated water when they turn on their tap. Now we can talk about costs a little bit. The total program to implement and integrate seawater desalination into our regional system was about $1 billion. And this is back in 2015 dollars. The plant itself, the construction cost was a little over $500 million. The pipeline was about $160 million. But then you need to look at the cost to finance this. The way that the private sector recovers its investments in the facility is by selling us water. So they are making money, as we purchase the water, we're slowly paying off the debt and the equity that was put into the plant. And so there's a 30-year financing element, and $200 million is needed for that. And then for the water authority, we also had some improvements that we had to do in our system to receive the seawater desalinated water. And so that was another $80 million. So the total price tag for us was $1 billion. When you convert that to how much we pay for water from the facility, again, we talk in acre feet. We pay about $3 million, sorry, $3,000 per acre foot. That's less than a penny per gallon, 1 cent per gallon. So while it is our most expensive supply, it is equivalent to or similar to other alternative water supplies that we're looking at. Cheap water is not out there anymore. Our groundwater is being impacted by the drought and by contaminants. We're not seeing the consistency of rain and stormwater capture or snow melt. So we're having to look at these new alternative water supplies like potable reuse, like stormwater capture, urban stormwater capture, and seawater desalination, and they all have a price tag around this amount. I wanted to show the schedule or process we went through to implement this job, because it took a long time to build the Carlsbad desalination plant. And this is, a lot of this is because we're in California. There are a lot of environmental and regulatory analyses and engagements that you need to go through before building a facility like this. You won't see this long of a timeline in a lot of the other places of the world, but in California, this is a reality for planning and implementing seawater desalination. As you can see here, we started thinking about this in the late 1990s. And again, we didn't have it constructed and placed into operation until 2015. A lot of that is because of the environmental review and the regulatory permits that we need to get to build and operate this type of a facility. We had a lot of engagement with the regulatory community, with the environmental community. They have a lot of concerns about seawater desalination. And so we have to work with that community to demonstrate that we're implementing all the right protections and engagement points where we interface with the ocean, both with the intake of water and the discharge of water, which I'll talk about a little more in the future. So there's a lot of review and a lot of monitoring that we have to do once it's in operation. But figuring out what that looks like takes a long time. This is a photo of our facility. This is the desalination plant. There was a power plant right next to the facility, and that was strategic. The facility for desal was co-located with the power plant. And the main benefit of that is the power plant was already bringing in water from the Pacific Ocean. So the intake and discharge infrastructure was already there. We didn't have to build that. We didn't have to pay for that. We just needed to tap into their discharge and pull that water in for seawater desalination. So how this process works at this plant, we don't have pipelines out into the ocean. There's a lagoon here that was developed to support power generation back in the 40s and 50s. And you can see the intake of the lagoon up here. So water comes into the lagoon. The intake for the power facilities is right here. They go into underground channels, go through the plant, and then out the ocean, out in the jetty right here. The power plant is actually no longer in operation. So the desal plant is now generating that flow of water into the lagoon and up to the plant. The facility brings in about 100 million gallons per day to generate 50 million gallons of high quality drinking water. And then there's 50 million gallons per day. So about half of the water that's brought into the plant goes back out into the ocean as concentrated seawater, also known as brine. We have to dilute that water prior to it going out to the ocean. And I'll talk about our monitoring and how we ensure that there is no impact in the ocean for this discharge that's going out in a future slide. Actually, I think it's my next slide. Yep, it is. So what this is showing, again, here is our desal facility. And here's the lagoon that brings the water into the facility. And this is where we discharge that brine. all of these points you see on the screen here are monitoring points, where 4 times a year, every year, Poseidon, the owner of the plant and the operator of the plant, has to take samples at each one of these stations and test for different constituents. We're looking at salinity, temperature, pH, dissolved oxygen, a lot of different components. And we're even looking at the sediment characterization. We're looking at the environment, the marine environment, and the classification of that environment. So, and all of this is to meet permit requirements. So this is a heavily regulated facility. And what we need to ensure is that we're not impacting the marine environment or the ocean with the operation of this facility. So it's something that, as a public entity, the Water Authority, our job is to provide a reliable and safe water supply, but we are also stewards of the environment. So it's really important to us that we make sure our interface with the environment, whether it's lakes, rivers, or the ocean in this case, is sound, and that we're not producing any unintended or any impacts to those areas. I'm going to get a little into the technical components of seawater desalination. Parts of it are like a traditional treatment plant, and then there's specific processes that are necessary to remove the salt and to pull the impurities of ocean water out. We go through a normal filtration through natural media filtration, where you're removing suspended solids. We have a second stage of pre-treatment through micronic filters. And these two processes are generally just really to remove the solids, suspended solids in the water, to protect the membranes. Reverse osmosis is the membrane separator that removes the salts and other dissolved components of the seawater to produce a almost pure water coming out of. From there, because the water is so conditioned, we actually have to put some hardness and back into the water. And so we do that with lime beds, and we also add additional post-treatment to that water, similar to any other treatment facility where you're putting disinfectant. We use chloramines at the Water Authority. We put fluoride back into the water, and we also make other adjustments to pH and corrosion inhibitors. Now, I want to kind of walk through so you can actually see what these different processes look like. This is the pre-treatment sand filters, where you have 3 different layers of natural material. Again, the water comes down through these materials, and the suspended solids get stuck, and they are then able to be removed from the process flow of water. These canisters here are where we have our cartridge filters that, again, are just removing smaller sizes of suspended solids before it goes through the reverse osmosis. This part of the building is our reverse osmosis, and it's the heart and muscle of the facility. This is where all of the salts are removed. And to do that, you have to pressurize the water up to 900 pounds per square inch. That's a very high pressure, and that's one of the reasons, or the main reason, why seawater desalination takes a lot of energy to produce the water. These reverse osmosis membranes are modular. So if you want to make the plant smaller, you just remove some of these. You can make it bigger. If you have the footprint, you could make this as large as you'd like to. This is one of the innovations, and innovation is key into seawater desalination. We do not have many seawater desalination plants in the United States. And one of the reasons for that is because it's a pretty expensive water supply. And the big driver of that is electricity. These energy recovery units actually reduce the amount of energy you need to run a desal plant by about 45%. That's because it's harnessing energy that is put into the plant through the reverse osmosis process and putting that energy back into the upstream flow so you don't have to pump that water. It's a complex process, but it has significant benefits in that it reduces how much energy you need by 45%. What you're looking at here is the last phase of the project plant itself. These are vertical turbine pumps, and so this is how we get the water up to and into the regional system. They have to pump the water 15 miles up about 1,000 feet, and there's no pit stop in the middle. These pumps do all that work, and this is the size of the pipeline. It's a 54-inch pipeline that is bringing that water into the regional system. So as I mentioned, this facility, it provides about 10% of our water supply. It's been in operation for 7 years, and we've collected a lot of data, a lot of information about seawater desalination through this facility. And we've shared that with a lot of different people who are interested in looking at or pursuing seawater desalination, not just in California or the US, but other parts of the world as well. It's a facility that we're very proud of. It has won a lot of awards for the Water Authority and for the community in terms of its resilience and reliability. We've just come out of another extended drought where we were looking at water cutbacks in California. And this is a facility that we're looking at is, again, not being the silver bullet for water resiliency, water reliability, but for improving that reliability as being part of the puzzle, part of the answer to achieving a resilient water supply. So, Ricardo, I'd like to stop there and hand it back to you, and I'd be happy to answer any questions.
Gracias, muchas gracias, Jeremy. Quisiera abrir el podio para quien quiera hacer alguna pregunta. Yo voy a empezar con una rápida. Quisiera nada más preguntar sobre el tipo de energía que utilizan. Me imagino que es simplemente energía que viene directamente de la red eléctrica. Y me pregunto si estudiaron la posibilidad de ejecutar un programa, un proyecto de energía renovable para proveer de electricidad a esta planta.
Great question, Ricardo. And you're correct. The power of this facility is we're just tied to the electric grid in San Diego. So the electric provider, San Diego Gas and Electric, and we get their power from them. But your question in terms of trying to decarbonize and transition to renewable energy, we can't just install the solar panels at the facility. This facility takes a lot of energy. So it goes back to that water energy nexus and us in the water industry partnering with the electrical and power industry to work on that path forward. Now, the state of California has a carbon neutral goal by 2045 with steps along the way to get there. And so over that course of time, we're seeing our utility providers change their portfolio, and we're seeing it become more green, more carbon neutral, and they're going to be required to hit that by 2045. So as that sector is changing, we'll see our component of that influence coming down as well in terms of emissions and things like that. Now, beyond that, we're also looking at, again, continued innovation to reduce the amount of energy it takes to process the water at the plant. We're also looking at being able to engage in the market as well, which we have that authority under our Water Authority Act, what we were formed under, but to look at and pursue wholesale power and marketable opportunities where we can then access specific contracts with green companies, with solar farms, with I listened into last week's webinar series about battery supply, battery storage, and so those are things that the Water Authority is looking at. While we don't have direct control or influence at this time, it is a key partnership and something that we need to work with the power utilities and the contractors who are developing those carbon neutral or carbon free green energy facilities. And so we will see that that trend continue. And in California, it's a priority to do that relatively quick.
Muchas gracias. Tenemos un par de preguntas en el chat. En caso de que me desconecte porque estoy teniendo un problema técnico, pero voy a hacer la primera. Muy interesante la presentación. No me queda claro, o quizá no lo escuché, el proceso de devolución de salmuera al mar respecto a la salinidad, temperatura. Creo que dijo que se mezcla y tampoco capté qué tan distinta sale el agua al mar. Es decir, ¿cuáles han sido los resultados de los monitoreos en el mar?
Thank you. Great question. And I did not get into much detail on that. So thank you for bringing me back to that. So there's two ways, two technologies or means of configuring your discharge from the seawater desalination plant. Most plants have a pipeline that goes out into the ocean a certain distance, 1,000 meters, and then it has dispersion facilities at the end of the pipeline that disperse the brine discharge so it doesn't have a localized impact at that discharge point. However, at this facility, we use dilution to meet the regulatory requirements of our discharge. So for every, I mentioned at the plant, we have 100 million gallons per day come into the plant. 50 is drinking water produced, and 50 million gallons of brine. Before the water even gets out to the ocean, we dilute that brine 5 to 1. So we bring in additional seawater to blend and dilute the brine before it goes outside this rock jetty and it enters into the ocean. This green area that you see on the map, this is our regulatory compliance condition. So this is our brine mixing zone. So once we get outside of that brine mixing zone, and that's about 600 feet, 200 meters radius from the discharge point, there needs to be essentially a non-detect of all the different constituents that they're sampling for salinity, TDS, dissolved oxygen. You need to not be able to tell that there's any discharge happening outside of that brine mixing zone. So we have monitoring that happens within the brine mixing zone, at the border, and then all outside. And in 7 years of operation, The facility has been in compliance with those conditions of its permit at all times. So there are some changes in the chemistry of the water within the brine mixing zone. We haven't seen that being a negative impact to the marine environment, but that's still being looked at, and we'll continue to be monitoring and ensuring that is not a significant impact. But the condition is that potential impact is limited to this small area, and then outside of that, you cannot see any impact. And the results of the monitoring and testing over 7 years of operation have shown that a well-designed facility can meet those objectives.
Muchísimas gracias. Había una pregunta también de Leonardo Pazmiño, pero me parece que la respuesta anterior cubre prácticamente todo. Hablaba cómo han reducido los residuos generados en áridos y en filtros. Y me parece que la respuesta que diste, en la cual mencionas el uso de una cantidad grande de agua de mar y la mezcla junto con los filtros, me parece que es la respuesta, pero si hubiera algo más que sea necesario añadir, te agradezco.
Yeah, certainly. So on the material that's captured in the filters, there is a little bit of solid waste that is removed from the plant and ends up in landfill. It's not a large amount. The seawater, mostly it's the salts that we're removing from the seawater, and so it's where we concentrate most of our focus is on that brine discharge. And one of the questions we get a lot, we give a lot of tours. Folks that like seawater desalination, folks that are against seawater desalination. And one of the questions we get a lot, especially from students in college and high school, are, with all that brine, is there anything else we can do with it? Is there a secondary benefit, a secondary use that we can use to reduce how much of it goes out into the ocean? And it's a great question. And that's one of the areas of innovation that I think we can continue to improve upon. A facility of this size and how much discharge that we have going back into the ocean, it's hard to reduce. It takes a lot more energy to reuse and put that water back into the system, to evaporate it, to capture the salts. But it is something we're looking at. There are constituents in that brine that are valuable for the pharmaceutical industry, for other manufacturing industries. There are some constituents that are reusable. It's a matter of finding out how to be able to extract that without increasing your electricity need. And so that's an area of innovation. It's something that we see a lot of research being done in, a lot of piloting being done in. But right now at this facility, it's been challenging to really reduce how much water we're discharging back into the ocean.
Muchísimas gracias. Abrimos para alguien más que quiera hacer otra pregunta. Pueden levantar la mano o simplemente abrir el micrófono y hacer la pregunta. Yo voy a hacer una más, perdonando. Una situación que he escuchado en Tocopilla es que se están realizando proyectos nuevos de nuevas plantas de desalinización. Me parece que los estudios ambientales se hacen tomando en consideración exclusivamente el efecto de esa planta y la área que va donde va a estar realmente alrededor de ella. En California, en el caso de que hubiera, es un caso supuesto, si hubiera una planta un poco más al norte de esta planta, los departamentos del gobierno tomarían en consideración la planta nueva como planta única, digamos, o requerirían que conforme cada nueva planta se va añadiendo al sistema, tienen que tomar en consideración los efectos ambientales de las plantas anteriores, o sea, la suma de todas.
That's a great question. In the state of California, we have a regulatory compliance requirements called the California Environmental Quality Act, or CEQA. And in those documents, they can be done at a programmatic level or at a project level. And in that process, you're evaluating the impacts that are caused by the construction and operation of a facility. And this isn't just for seawater desalination. This is for all major infrastructure. One of the things that is evaluated are cumulative impacts. So it kind of depends on how the project is being established. For the water authority at Carlsbad, this was a local regional facility. And so we only evaluated the impacts and mitigation required to build this facility and operate this facility. If the state of California were to look at a seawater desalination program that built multiple facilities along the coast, you would likely need to look at the cumulative impact of that. Now, the impacts are really local in nature, but that is something that would likely need to be addressed during that regulatory review that our state does.
Muchas gracias.
Ricardo, one thing I didn't mention, it kind of tears off of your question. There are impacts to seawater desalination, and the way that California looks at it, you have to identify what those impacts are, and then you have to mitigate those impacts. So one of the conditions of building this plant was to develop another 70 acres of new wetland habitat in another area in San Diego County. And so that is a huge mitigation and habitat restoration wetland development project that is being built and paid for by this project through our water purchase agreement to help improve the environmental quality in other areas, to offset any impacts that are deemed to be attributed to the construction and operation of this facility. So there are engagements that Poseidon Channelside is doing. They committed to planting millions of trees as part of their carbon offset. They're required to be carbon neutral. So they're engaged in the purchase of environmental credits and through the California's market program for credits and offsets on emissions. So there are a lot of environmental conditions and requirements that are ongoing and commitments beyond the plants that we are engaged in outside the design and construction of it.
Muchísimas gracias. Keith, ¿tú tenías una pregunta?
Yeah, I'm on two calls at once here. My question is, could you share about how many full-time equivalent jobs are associated with operating the plant? I think there might be some in addition to actual workers in the plant. In fact, like you just mentioned, this whole wetland project. And for those that are working with the plant, what are the common health and safety issues that you need to be aware of, and what sort of training might you provide to avoid health and safety issues in this sort of operation? Thank you.
Two very good questions. The first one I have to be general about. I'd have to get more information, which we could provide back to Ricardo and the group on the total equivalence of job creation from the facility. The data I received from Poseidon was the 2,500 jobs, indirect and direct, during the construction of the plant. Now the wetlands project, yeah, that's another very big project that is going to take 3 years to develop, and then 15 years of monitoring and engagements after that. And on the operations side, that 500 number that I presented was, again, a number from Poseidon that was direct and indirect. IDE has 42 full-time employees to maintain and operate the plant. But like you said, the engagement and needs for other resources and jobs is well beyond that. So I'll look and see if I can't get more data from that and share that with the group. Now I just talked my way out of your second question. Can you repeat that one again?
It was related to what are the most common health and safety issues for workers?
Yeah, that's again another thing that we're seeing in California, and I can only speak for California, is operators and maintenance workers at facilities. That job pool is getting smaller and smaller, and the complexity of the facilities and operating are getting more and more advanced. So training programs are really a focus point for our state to get more people qualified to operate and run these facilities. At the seawater desalination plant, it's a newer plant, so it has a lot of automation, it has a lot of controls, a very high-tech SCADA system. And so a lot of it, the operators run the plant in their operating room. They're not running around the plant and changing a bunch of valves and pushing a bunch of buttons. But the need to get more operators is certainly out there. And that training, we're seeing a lot more training programs. We're engaging our military industry. And as they are coming out of their military careers and moving into the private sector, we're seeing that they are a great resource to train and become operators and maintenance personnel at these facilities. But on the safety side, it is a complex facility. The biggest safety issue for seawater desalination is the high pressure systems that you need to have to remove the salt from the water, and that's specifically in the reverse osmosis building and that process. So there are a lot of safety protocols, a lot of safety training that goes into the operation and maintenance of these facilities. So it's something that IDE and the project owner take very seriously, and making sure that their staff are properly trained to work in those environments. You also have chemicals and chemical deliveries and chemical use at the plant to help facilitate the treatment process.
Muchísimas gracias. Creo que con esto podemos dar por terminado el evento. Si hubiera alguna otra pregunta que alguien que no pudimos atender, por favor nos envían un correo y lo haremos llegar a nuestro experto. Les agradecemos de nuevo el haber estado con nosotros. Les estaremos enviando la invitación para el próximo webinario, que será la próxima semana, y que tengan muy buenas tardes. Muchísimas gracias, Jeremy, por la gran información.
Muchas gracias.
Thank you, everyone.
Muchas gracias.
Chao, gracias.
Hasta luego.
útil.
Gracias a todos.
Chao.
Chao.